The vertex of our parabola is going to give us either the maximum for a parabola that opens down or the minimum for a parabola that opens up, value of y. And there are lots of applications where that's going to be interesting. For example, if we're a business, we would like to have the maximum possible revenue or the minimum possible cost for some process. There are two methods that we can use to find the vertex of a parabola, given that we have the equation that describes that parabola. The first method is called the vertex formula, and this is a formula to remember or to have on a note sheet. For a quadratic function, f of x is ax squared plus bx plus c. The coordinates of the vertex are given by the x coordinate is the opposite of b over 2 times a. So that's the x coordinate. There is also a formula for the y coordinate that you can look up and memorize if you love memorizing formulas. But the easiest way to get the y coordinate, once you have the x coordinate, is to just plug in. So our second entry is just y, which is just f of x. So find the x coordinate using this short, simple formula, then find the y coordinate by plugging in that x coordinate. Let's see an example of that. So this is still that revenue function from example 8. Y is negative 5x squared plus 10x, where y is the company's revenue from an item in thousands of dollars, and x is the price they set. Noticing that the x squared term is negative, and also thinking about all these graphs that we looked at, we know the graph of this function is a parabola that opens down. So it looks like this. It has a top. It has a maximum value, which occurs at the vertex. And so we can use this function to ask the question, what is the maximum revenue that the company can make from this item? And then we're also going to answer the question, what price did they set to make this revenue? So the revenue is going to be a value of y, and the price is going to be a value of x. So notice here, we're not given a value of y, we're not given a value of x. We're trying to find both x and y. And the x and y that we're going to find are the coordinates of the vertex. How do we know we're looking for the vertex? Because we're looking for a maximum. In the vertex formula, right, so our function is f of x is ax squared plus bx plus c. Our actual function is negative 5x squared plus 100x plus 0. So a is negative 5, b is 100, and c is 0. Our formula, I'm going to just grab the formula and bring a copy down here so that we can look at it at the same time as the question. Says that our x coordinate is the opposite of b is 100 over 2 times a is negative 5. And we could mess around with that, or we can just throw it into the calculator. That's the opposite of 100 divided by 2 times negative 5. And we get 10. If you get something other than 10, Probably what that means is that you didn't put parentheses around that denominator. Remember, whenever we put something with a fraction bar into the calculator, we need parentheses around the numerator and denominator, because that fraction bar acts as a grouping symbol, but the division sign on the calculator does not. So this works out to give us x equals 10. So the vertex has x coordinate 10, and then to find the y coordinate, we're just going to take f of 10. So that's negative 5 times 10 squared plus 100 times 10. And again, that's something we can just throw into the calculator. Negative 5 times 10 squared plus 100 times 10. And we get 500 for our y value. So the vertex is at x equals 10, y equals 500. What does that mean in terms of the story? Well, we just found a maximum value of y. So we found a maximum revenue. Y is in thousands of dollars. So our maximum revenue is $500,000. And how do we get that revenue? Well, the value of x tells us what price to set for the object. So we make that maximum revenue by charging a price of $10. That's what the value of x is telling us. Notice again, we weren't given a value of x, we weren't given a value of y. We were just given the function and asked to find the maximum. We wanted to find the maximum, and so that had us using the vertex. So we can find the vertex by hand using the vertex formula. We can also find the vertex on the calculator by using either the maximum command or the minimum command. Let's see an example of that next. We will especially like to find the vertex using technology if the coefficients in our function are really ugly numbers. And ugly numbers as coefficients is just a thing that happens sometimes. So in this next example, we have step-by-step instructions for finding the vertex on the calculator. And the example in our step-by-step instructions is that we're going to find the vertex for the function f of x is 0.031x squared minus 15.3x plus 219.8. So all of those are pretty ugly numbers. I don't really want to mess around with them in the vertex formula. We know that this function is going to have a minimum value. In other words, we know it's going to be a parabola that opens up and has its vertex at the bottom. And we know that because the x squared term is positive. Right, so this 0.031 is a positive number, so we know our parabola is going to open up. Okay, so let's throw this function into the calculator. So I'm going to just clear out our old example. Our function is 0.031 x squared minus 15.3 x plus 219.8. And now In this example, I'm going to kind of fumble around with my guess a little bit. Eventually, we're going to end up guessing that x is going to be between 0 and 600, but that wouldn't probably occur to us right away. If we come to this knowing nothing about this function, we might start out guessing, well, maybe our vertex is between x equals 0 and x equals 20. So we'll guess that. We'll enter our x min and x max, and then we'll say zoom fit to set the y values. And then we look at this graph. That doesn't look like a parabola. That kind of looks like a straight line, actually. I might double check that I entered my equation correctly. I did. I've got an x squared. So this graph really is a parabola. We're just so far away from the vertex, we can't even see it curve. We're so far away from the vertex, I'm going to jump my guess straight up to like 0 to 100 and see if that's any better. Okay, so I'm watching this graph draw. At least I can see that it's curved now. It's no longer a straight line. So 100 was still way too small, though. I might guess 500 or 600. I'm going to try 600 now. Say zoom. Zoom fit. Oh, that looks better. Now I see my graph come down and then go up again. I can see the vertex on screen. So sometimes we fumble around a little bit with the guesses. That's okay. We know we have a good guess when we can see the vertex. More generally, when we can see whatever we're looking for. But in this case, we're looking for the vertex. Okay, now, we are not trying to find the intersection of two graphs, so we're not going to use the intersect command. But we're going to use that second trace menu. And you can see that there are two options here that might be relevant to our interests. We might be interested in the minimum or the maximum. In our example, we know that the graph has a minimum but not a maximum. And so the command that we're going to be interested in is option 3, minimum. So we choose option 3, minimum. And just like intersect, this is going to prompt us to enter a bunch of things. I want to point out some things on the screenshots before we do this. Notice that it says calc minimum at the top here. So that tells us that we're in the minimum command. Now with intersect, we could kind of take the defaults for the first two. Minimum is a little bit trickier that way. We're prompted for a left bound. That needs to be left of the vertex. We're prompted for a right bound. That needs to be to the right of the vertex. And then in this case, the guess is kind of the easy one, because we only have one minimum on this graph. The guess can be anywhere in between. As long as our guess is somewhere in between the bounds, we're going to get the right minimum. So let's actually do this on the calculator. Left bound, I'm going to use the left arrow till my cursor is somewhere to the left of the vertex. Doesn't really matter how far away it is because we just have the one minimum here. Right bound, now I'm going to press the right arrow until my cursor is to the right of the vertex. And now we see that the vertex is between these two little vertical lines. So we've told the calculator where to look for a minimum. And now we put the cursor anywhere in between. and hit enter, and that gives us the minimum. So again, after each prompt, we hit enter to go to the next prompt. And after we get the last prompt, we hit enter to get the result. Okay, and here's our result. So we can see it on the calculator screen. We can see the same thing in the screenshots. So in our example, the minimum value of the function, right? So the value of the function is the output. I'm just going to round that to like the nearest whole number, just to save space. The minimum value of the function is negative 1668. And then the x value, we say it occurs at the x value. So we say it occurs at this number. And I'm going to round that to the nearest whole number too, 247. In a real world situation, we would know what we want to round to. In a homework problem, you'll be told what to round to. The minimum value of this function is about negative 1668, and it occurs at about x is 247.